So next we're going to take a deeper look at the bookmark command git push origin master. So first, you said you wanted to push your master branch to the remote master branch. But what does that mean? So big surprise, you have been on a branch this whole time. And we're going to do a brief aside from the world of network activities to discuss branches. We've been working with this thing called master, which is the default branch. What we need to know about that for now is that it is a pointer to a commit. Master points to the latest commit in our project. And as we add commits, the active branch updates to point to the newest commit, also called head. This is a screenshot from my Git visualization tool that I recommend, Fork. And when you copy an entire directory to a network location like GitHub, what does master mean in that case? You copied it. What happened? You actually created a copy of the pointer master, which is a duplicate pointer. It's got the same name, master. They're both called master, but one is on my machine, and one is a representation of master on the GitHub machine the last time we synced our data. So even though I'm not connected to the internet, my Git repository has a state that represents what github.com looked like, my origin, the last time I synced the data. So what fetch does is it basically grabs all that data. It doesn't touch anything on your machine. It just grabs the data, which is why you couldn't see the commits in my local machine. I just grabbed them. I didn't implement them into my project. But since branches are just bookmarks to the previous commit, in effect, every commit could be a branch. Logically, a branch is a place where your history can diverge. And with Git, your code can diverge starting at any point. Every time you make a commit, the active branch, also bookmark, is updated. So when we talk about branching, and this is something that gets people really confused, we talk about branching as if it's like going off to the side, but I never did that. I never explicitly said, I want to create a branch. I've been on master this whole time, and I've been on a branch. So next, we're going to learn how to use branches in our terminal. And to find out where your master commit points to, you can use the command git show master, which will show you the latest active commit on the branch master. And let's try that out. Git show master. That is the latest commit in our repository. Right there, that first batch of learning objectives. So when you run git branch, the command git branch, it shows you a list of the branches in your project. And you'll notice that one branch is green and has a star on it. If you made commits at that moment, the active branch would be updated to point to the new commit from that point. So to create a new branch, you actually use the command git branch and give it a name. And when I do that, you can show that I have two branches and it points to, I'm on master, that's the one that's active, that's the one that has the asterisk. Now, when I do git branch, I see that I have two branches, one that's inactive and one that's active. But both branches point to the same commit, which is the last one. So if I ask git to show master, it will point to our latest commit. But if I ask git to show new branch, it will point to that commit as well. That's because when you run git branch and you give it a name like another new branch, what you are saying is create a branch that points to the currently active thing. Voila. Branches point back to the currently active commit. So if we created two new branches from 8311b67, they would both point to the parent of 8311b67. And you can branch from any commit or even branch from previous commits using what we call references. The caret references the previous commit, and the tildes with numbers can move you back in commits incrementally. So for example, git branch planet master caret would mean create the branch planet one commit before where master is now. So in this nifty visualization tool, let's go ahead and do that now. So say I want to create a website about planets. Let's make a few commits to get the HTML up and running. And I am going to make a branch called planets and check it out. And I can do that in one smooth command with git checkout-b, call it planets. Great. And now I'm going to do a few more commits. And you can see that those are on the branch planet, which diverged from master 3 commits ago. So now let's make another branch. I'll use the same method, checkout B, and we're going to call it Saturn, and do a few more commits there. But let's see, now I want to go back to the branch planet and check that out and make another branch that points back towards planet. So I'm going to go back to and I'm going to make a new branch, Jupiter, and check it out. And do a few more commits on that. And you can see that head is on our most recent commit, Jupiter, and Saturn and Jupiter both diverge from planet at ACD6450. Our first exercise having to do with branches is I'm going to ask you to recreate your assignment workflow. So using the visualization tool that I just showed you, and I'll put the link to this in the forums as well, use this tool to recreate your assignment workflow. Choose an individual assignment from your course and recreate the workflow you expect from your students to complete an individual assignment. I'm going to ask you to take a screenshot of your results from the visualization tool and post that to the forums. And a last word on branches. If you want to see all of the branches in your current project, run the command tree.git/refs, and it will show you all of the trees and the remotes in your project. These are all the names of all the bookmarks in your repository. These are the local files that even show the branches in your remotes that your remotes pointed to the last time you fetched them. But what do you think are in these folders? What do they contain? So we're going to find out. We're going to ask git to get/refs/heads/new branch. It's a hash. Now, in your day-to-day workflow, you'll probably never look at these, but in terms of implementation, it's good to know. The implementation for branches is a file with a hash in it. The hash is the commit ID to which that branch points. So the implementation for branches is a file with a hash in it. When you run git branch, you're literally creating a small file on disk. And changing a branch is one I/O operation. It's super fast. So that's branches. And next we're going to move back to the world of network activity.